we are looking at question 2. We are still on the system of differential equation. Question 2 says convert the following differential equation into a system of first order linear equation. That's the first thing. Then the second thing to do, solve the system. The third thing to do in this question, use the solution to get the what? Solution to the differential equation. Okay? And we have this differential equation. This is a second order differential equation. This is equal to 0, and then make it to the what? To the second order differential equation. And then this is equal to 0, and then make it to the homogeneous second order differential equation. This is homogeneous, and we have the data given, the condition given. So without wasting time, step 1, introduce new functions. Okay, so we're going to start with x1, then it equal to y. Okay, this x1, can we get the differential of that? x1, then the next one will be x2, and x2 will be differential of this one, and that will be what? Y prime. Okay, so since it's second order, we're going to stop at what? It's always n minus 1 derivative. This is n minus 1 derivative, so we'll stop here. Okay, then the next thing to do is to differentiate this equation and this equation. So x1 prime will be equal to what? y1. And don't forget, y prime is equal to x2. Okay, so we've turned this towards first order linear equation. The second one is this one, differentiate this, and that what? This will be second differential. Okay, and this will be gotten from this equation, then we'll substitute. So let's come here and substitute. Don't forget your what? Your x1 differential. So this is first order linear equation is equal to what? Is equal to x2. This one is done. Then for this one, make the second differential, make it the subject. Okay? If you do that, and then you divide the equation by 2. This one by 2, this one by 2, this one by 2. Okay? Move this one to other side, move this one to other side. So that will be equal to what? 3y, and then over 2, then minus 5 over 2 first differential. Don't forget, you shift this one to the right side, it becomes plus. You shift this one also to the right side, it becomes plus, and then you divide by 2. And don't forget, your second differential for y is x2 prime, which is equal to what? Which is equal to 3 over 2. Y is what? x1 minus 5 over 2. Y prime, I mean this one, is what? Is x2. Okay? So this is done now. We've come back to first order linear equation. Then the condition also, we can also transform this condition so that it will conform to this variable. And this will be equal to what? Y is what? Y is x1 equal to what? Minus 4. Then the second one is what? Y prime. That's y prime is what? Y prime is what? Y prime is s2 equal to what? 9. So this one is in normal form now. Then we'll take you to the matrix form. In matrix form, we've turned it to the first order, solve the system. Okay? In matrix form, we're going to have this one, x1, x2 prime, and these two is equal to what? X is a vector prime. So, and that's equal to what? That's equal to we have this one, This one, you can write it as what? 0 x1 plus what? x2. So the coefficient is what we have here, 0, 1. The second one, we have what? 3/2 here, and then minus 5/2. Okay? And then times what? Times, there's no space here, let me do it here. So x1, the vector derivative, okay? Vector derivative, okay? We can call this one x bar prime, which is equal to 0, 1, 3/2 minus 5/2. This should be, this one will be x1, x2, but just write it as what? As this. Okay? Where this one is x1, x2. Then the conditions given. So we have this, and that's equal to what? Minus 4, 9. Okay? So that's what we have now. We've turned into matrix form, because for us to solve this system, it must be in matrix form. Okay? So then the final thing to do now, this is what we have now. For us to get the solution, we need to find the eigenvalue and what? An eigenvector. So this one now is conformed to this form. This conformed to this form. Okay, so that conforms to that form. So where A is the n by, where A is your n by n matrix. So A is your n by n matrix. So and this is the A. Okay. Then the next thing to do to get the solution to the differential equation is to calculate the eigenvalue and eigenvector. Okay, so let's get the eigenvalue first. To find the eigenvalues, we solve this system. Is the area is what we are looking for, is the eigenvalue. This is the identity matrix. Okay, and don't forget your matrix is what? Your A matrix is what? Is 0, 1, 3/2, minus 5/2. That's your A matrix. Okay, and to use this equation, this expression, to calculate the eigenvalue, very simple. Okay, this is determinant. I'm going to do that straight away. That's my determinant, equal to 0. Okay, the expression here is what? This is the leading diagonal, which is what? Minus r, minus what? Minus this. So that will be minus this, 1, 3/2, minus 5/2, minus r. Okay, so this expression is just this meaning of that, and then the determinant of that. The leading diagonal is one that changes. Others are elements in the matrix remain constants. So let's solve this. So this will be this one times this one. So that will be minus r times minus 5/2 plus this, and then minus 3/2 equal to 0. So we have 5/2 this, then plus r squared minus 3/2 equal to 0. So we can multiply 2 by 2. So that will be 5r plus 2r squared minus 3 equal to 0. Okay, do the rearrangements. Okay, so to factorize now, this one times this one, that's minus 6r squared. And the factors of this one is 6 and 1. So how can we use 6 and 1 to get a plus 5 here? So that will be plus this and minus this. Okay, the r squared, you can pair it, 1 here and then 1 here. Okay, and this is equal to minus this. So we now have 2r squared plus this minus 3. Okay, so pair this one and pair this one. 2 is common here, 2r is common, so I have this plus 1 plus 3. Here, minus, take it outside, minus 1, then I have this equal to 0. So we have 2r minus 1 into brackets r plus 3 equals to 0. So r is equal to what? 1 over 2 or minus 3. Okay? So let's calculate eigenvectors for r equal to minus 3. And to do that, we solve this system, which will be this, and your r is minus 3, so it becomes plus what? Plus 3 here. Okay? And the meaning of this is very simple. Just go back to your matrix. The leading diagonal plus 3 is the 3 here, 1 here. This one is u1, u2 equal to 0, 0. Okay? Then the augmented matrix. So that will be combinations of this matrix and this one. That will be 3 over 2, 1 over 2, then slash, a line, 0, 0. That's the augmented matrix. Then the row operation. What we want to achieve is to, second row, want to ensure that at least we have 0 here, at least on the second row. So how do we do that? That will be row 2 equal to row 2, 1 over 2, row 1. So that will achieve that targets. Okay? And that will be equal to row 1 is not changing, just a reference points. So this becomes 0. But by the time you multiply this row 1 by half, you have 3 over 2 and half on the first row. So this one also becomes 0. This also becomes 0. Okay? So we now have 3u1 plus u2 equal to 0. u2 equal to minus 3u1. So consider u1 to be x. So now have the eigenvector will be equal to u1 is what? u1 is x, and then u2 is what? Minus 3x. Okay, so we can take this x outside. Then we have u1 is plus this, u1 is that. So we have 1 minus 3x. Okay, so if you take this one to be 1, then this one, this vector is what? Is the eigenvector for r equal to minus 3. Then the solution for the system as a function of t will be equal to the vector, which is 1 minus 3 times the exponential to power minus 3 at t. Okay? So we've gotten the first solution. So this is the first solution. I can call it x1. Okay? Then to calculate now eigenvector for r equal to half. We solve the system. This one implies that just come back to the matrix A. So the leading diagonal minus half. So that will be what? Minus half here. This will be 1. This will be 3 over 2. This will be minus 5 over 2 minus 1 over 2. So that will be minus 3 here. Okay? Then this one, the component of this one is u1, u2 equal to this one. Then the augmented matrix. We have minus half, 3 over 2, 1, minus 3. Then this one, that's the augmented matrix. Then we do the row operation. Since we want to, the row 2 want to have at least 0 here, or everything zeros. Okay, so that will be row 2 is equal to row 2 plus 3 row 1. So that we achieve that target. So this is not changing. So this becomes 0, and this one also times 3, and then you add it together, that's 0 also. So we now have minus 1 over 2 u1 plus u2 equal to 0. So u2 is equal to what? 1 over 2 u1. Then we can multiply this side by 2, this side by 2. So we have 2u2 equal to what? u1. So consider u2 to be x. Okay, so the second eigenvector will be this, will be u1. U1 will be 2x, and then u2 is this. We can factorize the x outside, then we have what? 2, 1. Okay? So, if you take this one as 1, then this one, this vector is what? Is the eigenvector for r equal to what? 1 over 2. So we now have the second solution for that system as a function of t will be equal to that vector 2, 1 times exponential half t. So that's second solution. So the general solution now of the system will be equal to this one, and that will be equal to c1, and then times this one, 1 minus 3 exponential minus 3t, then plus c2 times q1 exponential half t. So that's the general solution. So what we're going to do now is to go to the criteria, the data given, okay, which is the functions of 0 equal to minus 4, 9. So that's what we're going to use to get the C1 and C2. Okay, and don't forget this one's a function of t. So t is what? 0, and that equals what? This value. Okay, I'm going to substitute that now. Yeah. So we now have minus 4, 9 equal to. If you substitute anywhere you see t, put 0 there, then you have C1 plus 2C2, and then the second one, minus 3C1 plus C2. So that's what we have now. This will now become, we now have C1 plus 2C2 equal to minus 4, then minus 3C1 plus C2 equal to 9. So we can solve this one. Can we multiply the first one by 3? This one times 3. So we have what? 3C1 plus 6C2, and then minus what? Minus 12. So we have the first equation, the second one, and the third one. Okay, so we can combine 1 and 3 together. 1 plus 3. So this will cancel. Then we have what? We have 7C2 here minus 3. So C2 is what? Minus 3 over 7. Okay. So with that now we can go to any of the equation and substitute. Okay. So that will be, let me use the first one. That will be C1 plus C2, which is this, equal to minus 4. and that will be equal to C1 will be equal to minus 4. This one will go to other side as a plus 6 over 7 equal to minus 28 plus 6 over 7, which is equal to. So the general solution will now become minus 22 over 7, then the vector 1 minus 3, exponential minus 3t, then plus c2 minus 3 over 7. The vector is 2, 1, exponential half t. Okay, actually this plus minus will be minus. Okay, so that's the solution for this system. Okay, so please, there is an icon of the video, click on it, subscribe. Okay, click on like button and send your comments. Okay, thank you for doing that.